Welcome to the video lecture Computer Networks. In this video lecture we are going to see in detail about Ethernet frame. Myself Samudha Pratima, working as Assistant Professor EC Department in RMK Engineering College. So we all very well known about 7-layer architecture of computer network. In that data link layer is a second layer between a network layer and the physical layer. So here the Ethernet frame on the wire, a data packet on the wire is considered as Ethernet frame. It is a data link layer protocol, and the frame as its payload consisting of binary data which is given to the physical layer. The Ethernet transmits data with the most significant octet first. So it consists of few number of octets. So within those octets, most significant octet will be transmitted first, but within the octet, that is within the each byte, the least significant LSB bit of the byte will be transmitted first. The internal structure of Ethernet frame is specified in IEEE 802.3. So this is the image which shows Ethernet frame. The Ethernet frame consisting of 7 fields. The first field is preamble, followed by start frame delimiter SFD, destination address, source address, type and data padding, and then CRC, cyclic redundancy check. And some of the Ethernet frames which are developed implemented for higher speed variants of Ethernet are called jumbo frames. For example, in gigabit Ethernet, we will use jumbo frames larger than the normal Ethernet frame. So let us see these fields one by one. So the preamble field will be used for synchronization purpose. It will be consisting of 7 bytes, that is 56 bits of alternating ones and zeros, to alert the receiving system to the coming frame and enable it to synchronize between receiver and the transmitter. And the start frame delimiter SFD, this field is nothing 1 byte field. It is 10 10 10 and 11. Instead of here 10 which is in preamble, it is 11. It will gives the last chance for synchronization, and here the last 2 bits are ones, binary bit ones. Alert the receiver that the next field is the destination address. So synchronization is over up to here, and then it will indicate the next field is destination address. So this is a example. So this 56 bits, 7 byte of the preamble bits are ones and zeros. First byte, second byte, third, fourth, fifth, sixth, seventh. So all the 56 ones and zeros will be transmitted first. So within this, the receiver must be synchronized with the transmitter. Next, SFD, start frame delimiter, byte is 10 It will give the last chance for the receiver for synchronization, and it will indicate next byte is the destination address. So after that synchronization happen between the receiver and the transmitter, the receiver will identifies the destination address next 6 bytes of the frame. It will consider as a destination address, and this contains the link layer address of the frame, since here the data will be transmitted as a frame which will working at data link layer. So the address is here data link layer address. So first 6 bytes will indicate destination address, and the next 6 bytes, that is the next 6 bytes after destination address will be considered as source address, from where the data will be originated. So it contains link layer address of the sender of the packet. Next, type field. This field defines upper layer protocols. Next, the payload field, that is data. Here the actual payload will be get from the network layer. It is a variable length field. This field carries data encapsulated from the upper layer protocols. It is a minimum of 46 and maximum of 1500 bytes. If the data from the upper layer is more than which can be operated by this Ethernet frame, it should be fragmented and encapsulated in more than one frame. If the data is less than 46 bytes, then it needs to be padded with extra bits. So if the data is less than mentioned bytes, then extra bits, zeros will be padded. If the data is less than maximum bytes, then it will be separated into more than one frame. Next, CRC, cyclic redundancy check, that is frame check sequence. So the last field contains error detection information. In this case, we generally use CRC32. The CRC is calculated over the addresses, types and data field at the sender side, and it is padded with the frame last byte. If the receiver recalculates a CRC and finds a non-zero binary number, then it will discard the frame simply by assuming there is a corruption in the transmitted Ethernet frame. So this is used for reliable data transmission. Next, as synchronized bits, that is from preamble, 56 bits, that is 7 bytes and 1 byte of SFD. Start frame delimiter will indicate starting of the frame, like that ending of the frame must be there. So actually the duty of the end of the frame is physical layer, by the physical layer. How means at the end of the frame usually indicated by loss of the carrier signal. Simply it is loss of the carrier signal. For example, in 10 base T Ethernet also, where the receiving station detects the end of the transmitted frame by loss of the carrier. Simply we can switch off the signal, binary ones and zeros. If there is no input, then it will be considered as end of the frame. So next, the overall frame length. So overall frame length, Ethernet frame length, it is a minimum frame length 64 bytes and maximum frame length is 1518 bytes, and minimum data length is 46 bytes, maximum data length is 1500 bytes. That is, Ethernet has some restrictions on both the minimum and maximum length of the frames. Ethernet frame needs to have minimum length of at least 64 bytes overall bytes, that is including preamble, that is 7 bytes of preamble, CRC, cyclic redundancy check, 4 bytes of cyclic redundancy check, 6 bytes of source address, 6 bytes of destination address. Everything if you calculated, it will become 18. So part of this length, so here actually if we then if the upper layer packet is less than 46 bytes, what will we can do means, we can pad up with పెట్టు ముందర పెట్టు, గొమ్మన పెట్టు, గొమ్మన పెట్టు. అంత ఎత్తుకొని పో సౌండ్ చేయబాక. So if the data from the upper layer is less than 46 bytes, then padding of zeros and ones will be happened, and if the data from the upper layer is above the 1500 bytes, then it will be divided into two Ethernet frames, and two extra frame will be sent. So this is restrictions imposed on the frame length of the Ethernet frame. Thank you.